Hello and welcome. Let's jump right into our question for today. The equation 3 to the power of x squared minus px plus 1 is equal to 27. Okay, so we're given that equation that has a quadratic expression in the exponent on the left-hand side. All right. So prove that the equation has real and unequal roots for all real values of p. Okay, so at first, this looks, to me personally, what first jumped out at me, so this is not even now getting to the second bit of the question, or the actual proving the real and unequal roots. I'll talk about what jumped out for me there shortly, but the very first thing that jumped out at me just looking at the equation is that 27 is a power of 3, right? 27 is equal to, oh my goodness, the troubles have begun. Right, so 27 is equal to 3 to the power of 3. And just as a side note, I think that it is so useful to invest in, I don't know if I can call it arithmetic, but just being able to identify things like this from the jump. Very helpful. So you want to kind of do things like, just intentional training your brain with these things, right? So learning the powers of 2, maybe up until 2 to the power of 10, 2 to the power of 5 at least, right? Learning what your square numbers are from 1 until, say, like 256 or something like that. Your powers are your cubic numbers. So say from 1 until maybe 6 to the power of 3, 216. Things like that are so useful in problem solving, because then there are things that can jump out at you even before you start diving into a problem. So I highly recommend that. If I happen to bump into a resource that's good for training stuff like that, I'll definitely plug it. Anyway, so right. Yeah, that was a long ramble about 27 and its beauty. Right, so just from our knowledge of solving equations where the unknown is in the exponent, the strategy is generally always to make both sides of the equation have the same base so that you can equate the exponents, right? So we're using the idea that if a to the power of x is equal to a to the power of y, then x must be equal to y, right? So that's why we make the bases, we try to make the bases the same on both sides. So this equation then kind of reduces or transforms into an equation that's just about the exponent. So we know that 3 to the x squared minus px plus 1 is equal to 27, and that must mean that x squared minus px plus 1 is equal to 3. That's the only way that that first statement can be true. So now we're dealing no longer with an exponential equation, but we're dealing with a quadratic equation, which then starts to make the second part of the sense of the question make a bit more sense. Well, that's a lot of making, right? We're asked to prove that this equation has real and unequal roots for all real values of p, right? And this is language that we're familiar with from the land of quadratic equations, because with quadratic equations we know of a certain somebody called the discriminant, right? The discriminant is right, we symbolize it with the delta symbol, and that is b squared minus 4ac, right? For, if in case we're wondering what is the b, what is the a, what is the c, which is a perfectly valid question, right? This is for an equation ax squared plus bx plus c is equal to 0, right? So the discriminant tells us what kinds of solutions to expect for a particular quadratic equation that is written in this way specifically. And that is because, well, you're familiar with the quadratic formula, right? Minus b plus or minus square root of b squared minus 4ac, the discriminant, divided by 2a, right? So because of that square root operation, that term right there is a very defining term in terms of how this equation is going to behave. If b squared minus 4ac is negative, then we can't take that square root, or at least not in the real number system. So we end up with what we call, well, how do we say it in high school? Do we talk about non-real solutions? I think we just say there are no real solutions, right? There are no real solutions because the square root of a negative number does not exist in the real number system. If the discriminant b squared minus 4ac is equal to 0, then that square root becomes 0. So minus b plus or minus 0, that plus or minus has no effect then. It's just minus b divided by 2a. So we end up with one solution, one real solution, or how we commonly say it is that you end up with two equal real solutions, right? Because minus b plus 0 divided by 2a and minus b minus 0 divided by 2a are actually the same number. So that's what happens when the discriminant is 0. And then when the discriminant is bigger than 0, when it's a positive number, then we end up with two distinct real solutions, that aren't equal, because then we're going to have minus b plus this number, which will give us one solution divided by 2a, and then minus b minus this number divided by 2a will give us another solution. So we end up with two unequal real solutions, right? So that's kind of a summary of why b squared minus 4ac, the discriminant, is so important when it comes to solving quadratic equations and framing what kinds of solutions we can expect for a particular quadratic equation. So that brings us back to this particular quadratic equation that we are dealing with for this problem, right? So it is currently not in the standard form of a quadratic equation, so we can't calculate the discriminant of this equation just yet, because remember, in order to do that, it needs to be in this form. That's when we can talk about the discriminant and in fact using the quadratic formula to begin with. So let's first sort that out. So we have x squared minus px plus 1 minus 3, right? We subtract 3 on both sides in order to get 0 on the right hand side, right? So that gives us x. I actually wonder if this would work out better with my finger. Let's try it out. Right, x squared minus px plus 1 minus 3 takes us to minus 2, okay, is equal to 0. So now our equation is in the standard form, and we can then work out the discriminant, right? So important thing is, okay, what is the value of a? The value of a is the coefficient of x squared, right? And whenever there is no coefficient for a variable, no, and I put no in quotation marks, right, we know that the coefficient is actually 1, right? We only have one of this thing, right? So a is equal to 1, right? And then what is the coefficient for the x term, right? Because that's our b. And the coefficient there is not just p, but negative p. Because remember, when we talk about the quadratic equation, a quadratic equation being in standard form, right, it's with pluses between the terms, not minuses. So we need to pretend that I am adding a negative thing. So that's why our b is negative. So b is equal to negative p, right? And then lastly, what is c? C is the constant, and again, it's not positive 2, otherwise it would have been plus 2. So c is actually negative 2, right? So we are now in a position to calculate the discriminant, because the discriminant of this equation will tell us what kinds of solutions this quadratic equation has. So the discriminant, maybe let's shrink stuff. So first let's erase stuff. I got very artistic with my highlighting, eh? Right, let's make stuff a little bit smaller. Maybe these guys. Oh, the two has left the building, y'all. I need to invest in somehow learning how to write straight. Oh, that's horrible. Yeah, it is a very, very needed skill, Shan. Okay, let's write this out because it looks weird. Maybe let's move them one step at a time. Hey, how about that? Okay, so that one is a success. Then, next up. Oi. Okay, maybe let's move these ones down here. I feel so sorry for people who watch this and are just like, just do the thing. The very obvious thing. I'm sorry guys, my brain sometimes takes a minute to catch up with stuff. Anyway, righty doos, we look like we are... No, it's not going to work. Okay, right, it is going to work. Oh, I just confidently erased that little 2. Oh, I'm still erasing stuff. The horror. Okay, little 2. Oh my goodness, it's gone. Oh, the horrors are continuing. Okay, right. Good. Now these guys can come back. I think this is the downside of not using the stylus, is that I now have very big fingers to deal with. Why do I always manage to scroll by mistake and I just can't figure out how to actually do it at will? One day. I will master you, app. Okay, anyway, right. After that very long ramble, we're finally ready to calculate the discriminant for this equation of ours. So the discriminant is going to be b squared, and our b is negative p. All right, very important to put our negative b in brackets because we're squaring that whole term, not just the p, but the negative as well, right? The negativeness of it. Right, minus 4 times a times c. Right, and that gives us minus p times minus p will give us positive p squared, and then we have 4 times 1 times negative 2, which is negative 8. So minus negative 8 is the same as adding 8. Right, so this is the discriminant for this equation over here, this quadratic equation. Now, what does this discriminant tell us? Okay, the first important thing is that we know that p squared is greater than or equal to 0 for all p, right, all real numbers. Okay, no matter what number you put in there, when you square a number, if you square a positive number, we get a positive result. If you square 0, you get 0. If you square a negative number, right, negative times negative, we know gives us a positive. So p squared is always going to be at the very least 0, right? And if on top of that, p squared plus 8, right? If you add an 8 to that, that means that, right, that's like adding 8 on both sides of the inequality that we started with, right? So p squared plus 8 is always going to be greater than or equal to 8. But very importantly, right, when we look at discriminants, what we care about is it equal to 0, is it bigger than 0, or is it smaller than 0? So we don't even care that it's bigger than or equal to 8. What we're very concerned with is that it is definitely always going to be bigger than 0, right? So the discriminant is always greater than 0 for this equation that we looked at, right? For this equation, can I find my laser pointer? Right, for this equation over here that we looked at, right, we've just seen that the discriminant is always, no matter what p you choose, the discriminant is always going to be a number that's bigger than 0. And therefore, what does that tell us about the solutions for this quadratic equation? It tells us that the solutions will always be, there will be 2 of them, and they will be distinct. They will not be equal, which proves the point that that we were asked to demonstrate, right? We are asked to show that this equation over here is always going to have real and unequal roots for all real values of p, right? So we've shown that, well, in order to solve this equation, we'd have to equate x squared minus px plus 1 to 3, okay? And we've seen that that equation always has 2 unequal real roots. And so our work is done. Of course, you'd have to write all of that down very eloquently, but that's the gist of it. And I think that, yeah, whenever you have a question where you're being asked about the nature of roots, right? That's literally what the topic is called when you learn it in school. What kinds of roots would this equation have? Then you kind of get the hint that, I need to look at the discriminant for some quadratic equation, probably. And then that kind of gives you guidance for where to try and go with your solution. Cool.